SwayamPrabha. Digital India. Educated India.
We will start this lecture with a thought process, that is, the idle mind rusts away like an unused iron. If you recall that in the last lecture we discussed about various applications and artifacts which were being used earlier days in ancient India, and that shows very clearly that Indians were knowing how to make these products. And also we discussed about how they were smelting the iron ore and producing the iron, and I argued that there are several varieties of, or there are several kinds of iron smelting furnaces across the country, and people were using their creativity and innovative ideas to implement them, and which cannot be done in the modern blast furnace. So, today we will be discussing about the iron and steel crafts in ancient India. We will have to use basically blacksmithing process for making a product out of iron, and this process is basically carried out in such a way that metal becomes soft. For this purpose, the wrought iron is to be heated until the metal becomes very soft enough for shaping with the hard tools such as hammer, anvil, chisel, etc. Of course, there are several tools one can use, which I have shown here. These are blacksmith tools like hammers, and of course, these hammers can be very small one, can be big one, even people use very big hammers for giving force. Chisels, punches, hardy tools, and tongs. Of course, these are tongs I have shown, pullers and flatters, and of course, there is a controversy whether the stone anvil was there or iron anvil, but anvil was there in ancient India. And these pictures, of course, I have taken from the recent one, but there are some figures from ancient excavation which are not good, that is why I have not included. And by this blacksmithing process, several products, namely light fixtures, furnitures, sculptures, tools, agriculture equipments, religious items, cooking utensils and weapons and others were being produced in ancient India. The blacksmithing techniques can be broadly divided into 4 categories. One is forging, and which is also known as sculpting, welding, and earlier days the welding, basically forge welding was there in ancient India, and of course, the heat treatments. I will be discussing about the heat treatment methods, and finishing. So, what do you mean by forging? The forging is a process by which the blacksmith shapes the metal to a desired shape and size for making a useful product, and for that purpose, of course, one has to heat the metal so that it will be soft, and then only you can apply the force in a proper way using sometime die and other things, so that it will take the shape whatever you want to have. For that, of course, the basic forging operations can be divided into various kinds, like lengthening. Basically, what you will have to do, lengthening means you are increasing the length of the metal when you apply the force in a proper way, in a one directional way, such that the length will be increasing, of course, it will be thinning down, the cross section will decreasing, and that is another way of shrinking. That means, if you compress it, it may decrease its size, length, and then it will be shrink. Then you can bend it, that is known as bending, and offsetting and swedging. Swedging is basically you put into proper dies and force it so that it will take the shape. Fuller uses the dies basically. And of course, there is a punching mark you want to have, then you apply some tool and then apply the force using hammer. And the last but not the least is the force welding. That means, you take two metals when they are hot and then you apply the force so that it can be joined together, that is force welding. So, if you look at these are the things which were being used in ancient India, and ancient Indian blacksmiths were having considerable knowledge about various thermomechanical treatments like forging and force welding, heat treatments and others. So, we will be discussing about the heat treatment process. Heat treatment process can be broadly divided into basically for the bulk material and also for finishing the surface. So, for handling the bulk material, what it can be done, that one process is being carried out is known as annealing, the other process is normalizing. Generally, the normalizing is carried out by cooling it in the air itself, and hardening and tempering. In this process, the cooling is carried out using water or the oil. And surface finishing is done by the thermal process and thermochemicals, because you use some chemicals and also apply some what we call heat, and then you can get a good surface. And during this heat treatment process, basically the physical and sometimes the chemical properties of materials get changed, and so that you need to play with that and get hardness, sometimes like malleable and other things, so that you will can provide a proper shape to the metal. So, this figure I have shown here, this is basically temperature, and this is the composition and particularly indicating the percentage of carbon in the iron. If you look at, there is a process, of course, this is a constant temperature around 700 maybe 27 kind of degree Celsius, and the annealing process, full annealing occurs at a various temperature for different carbon content. So, also the normalizing and also the spheroidizing. Let us look at what do mean by this annealing. For annealing of iron, it is to be heated to a high temperature, then it is to be cooled very slowly to the room temperature, almost room temperature. As a result, this microstructure will possess high ductility and toughness, but low hardness, and this has to be done properly, so that you will get this thing. And but whereas for normalizing process, the iron is to be heated and it has to be kept that high temperature for a longer period of time, and then of course, it will be cooled slowly in the air environment, so that the rate of cooling will be lower, or it will be lower as compared to when you are cooling with the water or in using oil. So, as a result, the microstructure will be changed, and generally a mixture of ferrite and cementite, which will be in a layer by layer, that is known as perlite, and being formed, and as a result there will be increase in higher strength and hardness of the metal, but with a lower ductility. So, this is basically normalizing. During this hardening process, iron is heated and kept at a proper temperature until all the perlite is converted into austenite, and then it will be quenched using the oil and water, any one of them, such that it will be cooling rapidly, and then there will be of course, the microstructures will be changing, and then you will be getting some kind of structure, so that it will be what you call very hard. And during all these three processes, the temperature and the heating time should be maintained properly, of course, which will be dependent on the percentage of carbon in the iron, so that higher level of austenite can be obtained. And the microstructure of a hardened steel consists of ferrite, martensite and cementite also. But if you look at it, is an art, and which has to be done really without getting into the detail of microstructures, because you need to have a idea about that what is happening, and of course, this comes from the experience and also certain procedures. So, I will just talk about little bit about ferric and carbon phase diagram, because we talked about various phases and then various structures, microstructures. If you look at here, at a very high temperature it will be liquid, and then of course, in this zone there will be some kind of structure which where we do not have much interest in that for so far heat treatment is concerned. But heat treatments is basically, if you look at in this temperature is shown, and in this the percentage of carbon. If you look at this is the steel is something around 0.022 to 2.17 percentage of carbon is known as steel, and then this 0.76 percent of carbon is a hypoeutected, and beyond this is hypereutected zone, and of course, the from 2.17 to 6.7 percent carbon is known as cast iron. If you look at this is correspond to A1, where here it will be ferrite structure will be there, which is a like a very soft in nature as compared to other microstructures. But as you keep this temperature between something 727 degree and then this region, okay, there will be alpha and gamma austenite, here it will be gamma austenite, and in this region of course, there will be what you call perlite and ferrite, and perlite and cementite in this region. Of course, this is the cementite region. But what is being done during the hardening is that like you put here austenite, and then you will be cooling it, and when it is a cooling the things you will be getting basically perlite and ferrite kind of structure, and this is occurring during basically annealing process. But whereas it is cooled very rapidly in case of hardening, it will be an austenite, but it will be coming suddenly to perlite and cementite, which will be very hard. So, if you look at these are the structures which will be being tried to maintain, because of that the hardness and then softness and then ductility, all those things we maintain. And I was talking about perlites. Perlite is basically these are lamellar structures, and these will be ferrite and cementite, and particularly when it is hardening, this what you call these will be converted what you call into more cementite structures kind of things, and the gap between these things depend on the temperature and the rate of cooling. But if you look at ancient metallurgists, particularly in India, they were not aware about all these structures. What they were knowing is a very hands-on experience, and they were knowing how to achieve final hardness by varying various characteristics. Particularly one is carbon content of the iron, and extent of cross sectional thickness of the object, because if you look at like the rate of cooling will be dependent on the cross section of the object, and also the how much time it will be giving for soaking. Generally the rule is that if it is 25 mm, you will have to go for at least 1 hour, but in principle people go for at least 2 hours for soaking at a high temperature. And final temperature object from which it is quench, that also they look at the temperature At that time there won't any instrument to measure, but they will be have a visual observation. From that they will be trying to guess what will be temperature and then do that. And of course, the severity of cooling during the quenching, they will go for air cooling or water cooling or for oil cooling kind of thing. And control of the phase transfer, proper heat treatment, they were just by guessing they were doing because hands on experience. And even today also you won't think that I will measure this one, they will will be doing, particularly the artist and in the rural areas even today, they know what is to be done. They may not be knowing all this what you call FEC phase diagram kind of thing, but they were knowing what is to be done. Let us now discuss about iron pillar, which is rustless. And if you look at this is the pillar which I have shown here, which is located currently in the Qutub Minar. You can note one thing, that this is having a increasing diameter, and it is being measured by various researchers, and some of them I have just put it here. And this is having a decorative portion of this rustless iron pillar. This amounts to be 60 unit. U basically related to 1 angula or inch. And if you look at it, is a diameter of this iron pillar is 12 U here, whereas at this zone it is something 16 U, and in this portion 24 U, and then again it comes back to the 24, and this is below the ground. This earlier days the original burial level is here, but now it has been gone to this portion, and there is a platform below which support this iron pillar. And similarly, the length of this what you call portion, which is 40 U, what is existing today, but people are thinking there was some emblem here below, above it, and that is why they are thinking of 60 unit if you put that thing. And from this region it is something 180 U, and this is 60 U from this, when it is increasing its diameter and having a very good nice curve way. And it if you look at it, is like a cantilever. I mean, they were knowing that this has to be more so that it can support the thing. So 18 U is this one, this portion, and this in 18 U, these dimensions, right. And of course, it is being claimed by several authors that ancient measurement system was adopted by British system, but it is questionable, and one has to do more research to find out whether it is true or not, or maybe it is just a false claim. So from this you can note that dimensionally they were maintaining the object what they were producing. For maintaining a dimensional tolerance is not that easy even today. So let us see how they might have created this rustless iron pillar, which is considered to be the one of the wonders in the entire world. And this is again what I am showing here is basically hypothetical, and there is no evidence how they made it, but people are thinking they might have made this way. This is a pedestal they will be making continuously. Of course, this is the staircase, right, through which people will be going at the top, and they will be using some iron. These are the iron which is hot iron pieces, and they use what you call bellows. This is basically bellows, and this is a tongue which will be they will be holding this piece of iron. They will heat it and take it from here to this region and then place properly, and again they will be heating. These are all what we call heaters or heating furnace, you can say, right. And they will be applying this force with the help of a big hammer in a continuous manner, so that it will be force weld with that. This is known as handheld hammers, and this is vertical forging technique. This is basically vertical forging technique, what people are thinking they might have done, but nobody knows how they did it. So, there is a even with these people are anticipating, instead of what we call handheld hammers, which is having limitation, they might be using a hammering rod with a pulley and then rope systems, and again the same process they will be doing, like they will be heating these iron blooms, and then they will take this and place it and then go on hammering, so that it will be welded. And if you look at, and as this height of this pillar goes on increasing, they will be increasing this pedestal. It is a very painstaking job if you look at that way. Whether they did in this way or they have used some other way, like another way one can think of is horizontal method, that is horizontal forging technique. They will be using a peg here, and this is your iron pillar to start with. There will be peg which will be, they will be easy to rotate, right. They will be rotating this peg, and then they will be, there is a furnace here, and of course handling clamp they will be fixing here, and then what they will put in die or anvil, and they will take this iron lump which is heated one, and they go on hammering it to the proper size, and then they will also rotate this one what you call a continuous manner, and putting this iron lump, and so that they could have produced this thing. And as I told, this is the hypothetical, because they will have to lift up and then down, then rotate it, this thing. And there is of course similar way, instead of using hammer, what they will be doing is that they will be using a hammering log made of maybe iron with a hardness, higher hardness, iron plate they might have fixed. Of course, this can be a wood, right. They are thinking it will be wood, timber, and then they will be having a iron plate. They could have joined it and then hammer it, such that it will be making this. This is a basically iron lump, and right. And this die will give the shape, because die should be hardened, otherwise die will get spoiled in the process. Of course, in this case it will be horizontal force which will be acting due to the movement of this wood log, and also the with the iron plate, but they might have made this way. So, these are the hypothetically people are thinking that they might have made in this way. There is a possible use of dies. For example, there will be a die block and they will be heating it, and then iron pancake they will put it here and then hammer it by the force, or they will be using a hammering log which I had described just now. And there is another way of that, the similar way, that is a pillar, and then this a die block, and then die block can be put together and they will be rotating it, and support it will be, and then hammer from this side, and so that they will be making the force welding operation to take place. Of course, for these purposes one can use what you call, this is the, when it is a vertical pillar making, and they will be using the charcoal, and this generally wooden charcoal, right. They will be using, and bellows for the supplying the air, air will be coming out of this, and of course, this is for the horizontal pillar making process. So, by these people might have done, and one can see that like how it is. Of course, a lot of other research are going on. I am just showing some of them due to paucity of time. A lot of work has been carried out on this metallurgy of the iron in India, and this data is corresponding to ultra sound measurements. What they are doing, they are putting a transmitter, right, and which can produce this ultrasound, and then you will be putting this receiver at each point, and then find out how this intensity going on, what is the speed velocity at which the sound is propagating, and at different location they have taken. They have taken in what you call 41.1 centimeter, and then like at this diameter, this is 1 meter, 2 meter, 3 meter, 4 meter, 5 meter height corresponding to different diameter, which is shown here, the 41 point and then 38.2 at different, like this is, if you look at, this is your A, B, and this is your C and D and E. So, and these corresponding to the sound, and from this they could find out that there is a places, right, that sideway addition of iron metal in the main pillar lying horizontal position. They are thinking that these lumps of thing are being placed on the side. As a result, what will happen, this velocity is not symmetric, right, it is changing. Because of there is obstruction, there will be metal surface which will be still lying, there is 2 metal lumps having a surface, so that it will not allow the sound to come, it will be reflecting back. As a result, from this they are saying that in ancient India, this iron pillar could have been made in a horizontal position, and that is the conclusion they are making, because these are different in some cases. For example, here it is very clear, this sound is different than this, because this is 6000 meter per second, and this is basically, if you look at, is a 4500 to 5000 meter per second. So, that is the conclusion they have made from this measurement. And as I told you, the decorative bell capital, this is, if you look at the dimensions are given in terms of U, like it is a various complicated, looks to be very complicated, and having this thing, if you look at this bell shape, this is the like a inverted colors kind of thing, and that is 1/3 B. B is basically corresponding to 16 U, and this is also B, right, 1/4 B. Now, how they are maintaining these curves, and then what are the this dimension, these are the big question which is coming to our mind. And the actual figure it shows, these are of course the diagram and a drawing of these actual figures, and it looks to be very beautiful, and a question might be coming to your mind, why they are made so attractive and decorative in nature. One interpretation is that this is the basically a this portion the having a Purna colors, and is a bowl of plenty. And we know that always Indians were very much interested to have the ultimate goal of life of attaining spiritualhood, that is attaining the perfection. And what we say is that Punnamidang Punnamudat Punnamudachyate Punnasya Punnamadaya Punnameva Vashishyate. That means you will have to attain the perfection, that is the ultimate objective of life, and this is being placed in front of a temple. So, therefore, people will be coming and trying to look at themselves and then go back and then work for this attaining the perfection, which is the ultimate objective of life, so far the Indian philosophy is concerned. And it is not only here, it is all our auspicious occasion, there will be a pot which will be filled with water, and that also indicates or gives a signal to us that we will have to attain this perfection in as a human being. So, of course, this portion of Garuda which is being shown here is not there, and but people are thinking that Garuda shape might be here, which has been removed from the original structure, and might be again the Vishnu will be there here. And people are also telling that this there might be another one, like this Nakshatra Chakra, which was having giving some idea about various nakshatras, and some people are interpreting that there might be a Sudarshan Chakra which is being generally being used by Lord Vishnu, and these are being basically made of maybe copper during the Samudragupta periods, because they are how they are anticipating it, they are taking this idea basically from a copper coin which was being invoked during the Samudragupta period. That might be the thing, but how they made this thing, of course, they are thinking that it will be made of not iron, but maybe some other bronze or some other metal. And let us look at this multi-sided circular disc, which is having 20 sided disc in the upper one. If you look at this is one of them, right, and how they were making these things, that is a one thing. And of course, they have made 16 sided circular disc. Why this change? One can think of, I mean, like, these are all mystery, one has to research, find out why it is. And this is the reeded slanted section, this portion is the slanted section, how they are made. And there is another section comes the bell shaped inverted color shapes, saying how they are made out of this is a one question might be coming into pictures. And this is the thing what I was talking about, these are the 20 faces and these are 16 faces and these are slanted one, and this is the your bell shape what you call inverted colors, like bowl, inverted bowl or inverted colors you can call. Now, how they have manufactured this thing is one question might be coming to your mind. Lot of hypotheses being made, what I will be discussing is hypothesis, because there is no evidence, there is nothing written that how they have made about it. So, one of them what one can think of that, you know, these are the shape, I have just magnified it here. If you look at these are rod, right, it will be having a rod kind of things, these are all iron rod. Okay. And they might have taken an iron rod here, one rod, and then bend it and put it here. Like if you look at, if I look at this is the rod what they have taken, and they have also flattened and make this curve little bit. In between there is a one single rod. This is the bend rod, right, and this is the single rod they have made, and then force welded to this portion. That might be the one way, but how they were maintaining the tolerance of the rod diameter is one question might be coming. And also beside this they were making it little flattened. If you look at this portion, you know, this portion is little more diameter than the inner one, and flattened also they make a curved one. What shape they will be using, how they are maintaining this and managing this shape is also one question coming to my mind. And these are the things one has to do, that maybe somebody should replicate, and what mind and then concentration power and the judgment power those people will be having who had made this thing. So, let us look at how they, and there is a thing whether they have made this thing in a single piece or they have made each pieces and then you know, assembled them together. That is one questions coming to mind. But what people are thinking that there might be use some you know, different pieces they might have manufactured, and then like this, you know, this is the inverted colors and this is the ring, and then these are the all ring kind of things, and they have fitted. Now, of course, there is a decrease in diameter. If you look at this is diameter phi and then phi 1 and then this is phi 2, phi 2 is greater than phi 1 diameter, and then of course, you know, it will be easier for them to put together. So, that is a one way of by pressure they will be using it, and then you know, so that, but then how they will be matching this diameter properly, so that why it will not go here and there, you know, like that is one. There is another way of people are anticipating, they will be using a hollow cylinder here, this is the hollow cylinder, right, and they will be putting this each individual components on this what you call the hollow cylinder with a thin wall thickness, and then they will be putting this insert and then hammering it using the force, right. As a result, it will be shrink fitting kind of things. That is another way of doing, but which is the correct one and how they did, all those things has to be studied and then one can look at. But even if you consider these things, that itself shows that what is the craftsman they were having and what is the technology they were having doing that at that time. So, therefore, it is very important to appreciate their skills of making this not only the iron pillar, but several of them, but I am discussing iron pillar now. And then why question arises, why is iron pillar rustless? That is the question might be coming. Of course, lot of research has been done on this, but there is a lot of diverse kind of opinions being made by various researchers. I will be discussing about something which is very simpler, being explained by the late Professor Balasubramaniam of IIT Kanpur, and I have taken this thing from his book on iron pillar. So, let us consider a metal mild steel, which will be having of course no other like chromium, nickel, other things. As a result, what will happen whenever it will be coming in contact with the atmospheric air, oxygen, and particularly and also the moisture, then what will happen, several oxyhydroxides will be forming, like let us say gamma FeOH, and because this iron will be containing Fe iron, and also the H and O it will be there in this compound, and then this creates something like a discontinuous layer near the metal, like if you look at this one layer, and this also there is another kind of alpha FeOH being formed sometime, because with time this gamma FeOH is converted into alpha FeOH, which is known as zeolite, and this gamma FeOH crystalline structure is known as also lepidocroside, and this being what happened, like there will be a crack in between, and which will allow this oxygen and the water to come in contact with the metal. As a result, the rusting will be occurring, because oxide will be formed and then the rusting will be occurring, and this as a result rusting cannot be prevented by this. But of course, in the modern time people do add copper, chromium, nickel. Of course, chromium, nickel are being used nowadays very much, and of course, some people have started adding phosphorus in a small quantities, and this creates a delta oxyhydroxides layers amorphous, which is amorphous in nature, and this will be acting as a protective layer between the what you call the atmosphere and the metal, virgin metal. Of course, on the top of this delta FeOH layer there will be alpha FeOH and gamma FeOH, there might be crack in between, but however, there will be amorphous in nature, therefore, it will not be any crack and it will act as a protective layer. So, that we will get rustless iron, they like a stainless steel iron and other things. But in ancient time, that what people are using in Delhi iron filler particularly, they were use the metal containing a lot of phosphorus, certain amount of phosphorus. The good thing about this, that it will be reacting with the water and also the oxygen when it is exposed to the atmosphere. In the beginning, of course, there will be some amorphous delta Fe layer will be there might be crack, there might be little bit rusting will be there maybe. But as the time progresses, this layer, protective layer, the iron hydrogen phosphate hydrate layer, which will be thickened and then it will be very protective. With respect to time, time means not hours or days, it will be years together, and this became more rustless, and that is being occurred due to the alternative wetting and drying condition, because in the rainy season it will be lot of moisture will be there, in the winter season moisture will not be there in the air. So, therefore, that will be going on, and that helps in building this iron hydrogen phosphate hydrate, and also its thickness increases. As a result, you will get a rustless iron with the time, you know. So, generally it is other way, and if you keep the steel for longer, stainless steel particularly for longer period, rusting will be occurring, but in this case that will not occur, it is just opposite of that. So, therefore, with this I will conclude that iron is the part and parcel of Indian civilization, and modern iron steel making is quite costly and environmental unfriendly, as I had discussed earlier lecture, and olden days technology quite small in scale, which can be adopted by semi skilled people, and thus generate employment and least pollution as distributed across larger area, and people can innovate on it, and because there is a lot of scope for people to carry out innovative research and implement very easily in this older iron making furnace, and corrosion resistant irons used in iron pillar can be adapted easily, skill possessed by the people, not by the machine or the what you call very few people companies make our people to realize their potential while developing excellence in life. So, more research work on the understanding and reviving this old technology for making iron must be carried out in future. It is not that only for iron we will be doing research, we will be doing also to revive old technology maybe in a little modern sense, so that it can be accepted by the people. Thank you very much.